Hello students, welcome back to the math class. Today we are going to start converse of midpoint theorem. First of all, we shall see what is converse of midpoint theorem because the questions we have seen of 8.2 exercise, in that we didn't use up till now the converse of midpoint theorem. Okay, initially 3-4 questions whichever we have seen, in that we did not use it, but now for the remaining set of the question we have to use a converse of midpoint theorem. First of all, once we shall quickly recap what is midpoint theorem, and then we shall come back to the converse. See, earlier I have explained you the midpoint theorem, that theory and the statement is in front of you now. Suppose we have given that one triangle ABC, you can see the figure. E and F are the midpoints. E is a midpoint of AB while F is a midpoint of AC. Now these two sides AB and AC midpoint we have given. When you join these two midpoints, the line joining the midpoint of two sides will be parallel to the third side. Okay, who is the third side here? The third remaining side is here BC. So the line joining the midpoint means EF is parallel to the side BC, and not only parallel, it will be half of the BC as well. So to apply the midpoint theorem, you required mainly two midpoints of the two sides of a triangle. Okay, now see, the confusion will start because we are handling simultaneously midpoint theorem also and converse of midpoint theorem also, and both the theorem have different given and their result. However, sometimes the converse, we can say that it is exactly opposite to the main theorem whichever is given, but every time it doesn't happen. It is partially opposite also, we can see. So here, midpoint theorem, remember E and F, we require two midpoints, and if we join that midpoints E and F, that will be parallel to the third side or the side opposite to it, and they will be half of it. That is your midpoint theorem. Now we shall learn what is converse of midpoint theorem. Okay, converse of midpoint theorem statement you can see first. What statement they are giving? The line drawn through the midpoint of one side of a triangle parallel to another side bisect the third side. Okay, now with the help of statement, each and everything will not be clear. I will explain you with the help of one figure. As you see, the triangle ABC is given over there. I say here, according to the theorem, we have given that E is a midpoint of AB, that is given. Second given is there, EF is parallel to BC. So we have basically two given will be there in the converse. First is, in place of two midpoints, we will have only one midpoint. E is midpoint of AB. E is midpoint of AB. That is the one given. And second given will be the line through E. Which line is going through E? That is EF. Okay. Further, so we can say that the EF will be parallel to BC. That is the second given. You observe EF parallel to BC were the result of midpoint theorem. Okay, so here EF parallel to BC will be a part of given. So you can say that partially we can say yes, the result has come at the place of given, and given is going at the place of result. How? See, in the midpoint theorem, F was also given the midpoint of another side AC. Okay, here in the result we will say that then if we get these two given over there, then we will say F is midpoint of, F will be a midpoint of side AC. That is the required thing in the result. Okay, so one more example I will give you if required, because this example may not be sufficient. So one more example I will take. Now you look at carefully how the figure I am drawing it, and I am taking the example here. Okay, suppose leave this part, and if I draw one triangle over here like this, and the name of this triangle I am giving as P. Here I am giving Q, okay, and here I am giving R. And one line I am drawing here. Suppose the line I am drawing here from PR to PQ, like this, okay. And here this point I am taking the name as M, and this point I am taking the name as N. Now see, here to apply the converse of midpoint theorem, what given you need? In here you required, the required things you can say, or you can say it is given. First of all, out of M and N, you required one midpoint. Either M should be a midpoint or N should be a midpoint. For example, if I say PM is a midpoint of PR, sorry, M is a midpoint of PR. So here one given should be M is a midpoint of PR. That is the one thing. Second thing, what do we need? Second thing we need here, the line going from point M, that is MN. MN will be parallel to the side QR. Okay, whichever the line is going through the midpoint, that will be parallel to QR. Then in that case, what will be the result? The result, we can say that in that case N is midpoint of line or side PQ, that we can say. Okay, so remember, this is a theorem is between three things only. One is out of the 2 point, one should be a midpoint. From that point, the line drawn should be parallel to the third side, that is your given. And in the result, the remaining point at the another end, that will be also midpoint, that you will get in the terms of result. Now let us see the first question based on converse of midpoint theorem. Now in 8.2 we have remained only 3 questions. Question number 4, 5 and 7. So let us see the question number 4. Now, see in the question number 4, what we have given here, we have given that ABCD is a trapezium. Now, since ABCD is trapezium, so one pair of opposite side would be parallel. So, AB is parallel to side CD. BD is a diagonal. Okay, you can see the opposite vertex they have joined. And E is the midpoint of AD. See, it is the main important point is given. E is the midpoint of AD, that is given to us. So here if it is required, I will mark ED and AE are equal. Okay, and a line is drawn through E parallel to AB, means from the point E, whichever the line is drawn, that line you are seeing enclosed by the two arrows, that is parallel to AB. So simply we can say that EF is parallel to AB. Okay, because two points are there on that line, E and F, so the part of that line will be also parallel to AB. Intersecting BC at F. Okay, show that F is a midpoint of BC. We have to show that F will be also midpoint of BC. First of all, we'll make one small modification in the figure. This point I am supposing here as O. Okay, any other name also you can take. First of all, I will write down the given things here. So in the given, we shall mention first ABCD is a trapezium. ABCD is a trapezium with AB parallel to DC. Second thing, what we have given here, E is a midpoint of AD. So second we will write down here, E is a midpoint of AD. Okay, that is the second thing. And what else we have? EF is parallel to AB. That is also given in the question. You can see. Once again, I will show you. Sorry, a line is drawn through E parallel to AB. Okay, so line through E means this line, middle line they are talking about, and it is parallel to AB. So EF and AB are parallel. Now what we need to prove here, that we will mention. So now we shall write down here, to prove F is midpoint of BC. F is midpoint of side BC. Let us start the proof now. So in the proof, first of all, see, we shall take one triangle. Now I will show you separately because converse of midpoint theorem, sometimes it confuse to the students. Okay, so here I am taking one triangle. So separately I am drawing one triangle here also for your convenience. Look at this triangle, one triangle I have taken. Now I am not drawing exactly the same way as it is drawn in the main figure. Okay, but assume it, one triangle I have taken and one line I am taking here. Okay, now the name of this triangle I am taking as, from the figure you observe, the name I am taking here D, then this will be A, this will be B. Okay, and this point I am taking as E, and this point I am taking as O. Okay, you can see one triangle DAB is there, and we have one line EO is also there. Okay, now first of all, you remember in converse of midpoint theorem what I told you, the required things. Okay, same exactly we are going to get here. First of all, we shall write down in triangle DAB, in triangle DAB. See, the first requirement of converse of midpoint theorem is out of E or O. See, they are only coming in the middle. So out of E or O, any one required as a midpoint. So see, E is given as a midpoint of AD. So we will write down E is midpoint of AD. Okay, that we can say with the help of given. Second, we required EO should be parallel to AB. So see, already it is in the given. We have mentioned EF is parallel to AB. So if EF is parallel to AB, part of EF will be also parallel to AB. So we'll write down and EO is parallel to AB. Here reason will give since EF is parallel to AB. That is given in the question. Okay, now see, these are the two main requirement of converse of midpoint theorem. One, out of E or O we require the midpoint. Second, the line from E should be parallel to the base or should be parallel to the third side. That is also we are getting it here. So now we will write down, therefore by converse of midpoint theorem, converse of midpoint theorem, what we can say, the remaining point means O will be also midpoint of the respective side. We can say that converse of midpoint theorem, O is midpoint of side BD. That one important result now we have achieved. Now further, see, now to go further, our ultimate task is to prove F is a midpoint of BC. Okay, in between that we have proved O is a midpoint of BD. It will help us to prove the required things. Now to get the required things, we required one more thing. First of all, you see, AB is parallel to CD and EF is parallel to AB. So we can say that EF and CD will be also parallel because EF and CD are commonly parallel to AB, and we know that if two sides are parallel to the same side, they will be parallel to each other. So that only we shall mention first. So now we shall write down in the solution further. Since AB is parallel to DC, how we can say? That is given in the question. Okay. Second, AB is parallel to EF. That is also with the help of given only we are saying. So we'll mention this is also given. So therefore we can say that DC will be parallel to EF. Okay. Now again we achieved one important result, we can say. Okay. Now let us draw the triangle once again. It is possible to copy. It is not allowing. Okay, we can copy first triangle because again one triangle I required here. So this triangle I am taking it little downside. Okay, I am placing the triangle here. Same way that line also will be required. That line also I am placing here. But now this time I will change the name of the triangle. Okay, now see, triangle I am taking different. Now that triangle will not be looking in a proper manner. Observe, I am taking a triangle BCD. Okay, are you looking one triangle there? BCD, and in between that two points are there, O and F. Okay, so now see, here I am making a triangle in a proper manner. I have a triangle here B, C and D. Sorry, D I will take on this side. That will be more better for you. D, and here I am taking C. Here point O is there and here we have the point F. Once you check, O is on side BD, or you can say that diagonal BD, right? And F is on the side BC, and we have triangle BCD here. So as per the things given in the question, I have drawn the triangle, but now it is completely understandable. Okay, so now see, in this triangle again we have O is a midpoint because we have proved it earlier. You see, we have proved here O is a midpoint of BC. Okay, second thing, now we have OF is parallel to CD as well. Now you will say, where we have proved OF and CD are parallel, but just now we have proved CD and EF are parallel, and see, CD and EF. Okay, look at here in the main figure. CD and EF we have proved parallel, so CD will remain as it is, but you see OF is a part of EF, so OF will be also parallel to CD, that we can say, and that is only required in the question. So OF is parallel to CD because EF is also parallel to CD and OF is a part of CD. So here further we shall take the final solution we are writing here. First we'll write down, now in triangle BCD, O is midpoint of diagonal BD or side BD, that you can write down as proved earlier. Okay, second we'll write down, and OF is parallel to DC. How we can say? Since DC is parallel to EF, now we can write down therefore by converse of midpoint theorem. By converse of midpoint theorem. We will get here F is midpoint of BC, and this is only the requirement of the question. F is midpoint of BC. That only they set to prove to us. So now we can write down here, hence proved. Okay, let us start now the next question. I hope this question is clear because these questions are very lengthy and we are doing the core part of the geometry. After this, one more chapter remain, that is circle. In circle maybe some part is reduced, that we will see afterwards. Okay, but in this chapter there is nothing is reduced by CBSE. So let us see the question number 5. In the question number 5 we have given that in a parallelogram ABCD, E and F are the midpoints of side AB and CD respectively. Show that the line segment AF and EC trisect the diagonal BD. First of all, you should understand what is the meaning of trisect. Trisect means three equal parts. Suppose if I want to divide 9 into three equal parts, so one part will be here 3. So we can say that 9 I have trisected into three parts. So value of one part will be here 3. So dividing a given thing into three equal parts is called as the trisect. Similarly, bisect means two equal parts. Okay. So here, first we shall write down the given things in this question. First of all, you see the given figure is now in place of trapezium, we have given that parallelogram. So now we shall write down ABCD is a parallelogram. And second thing, we have given that E and F are the midpoints of side AB and CD. So E and F are midpoints of side AB and CD respectively. Okay, this is the only second given to us. Now what we need to prove here, that we shall clarify properly. Okay, see, they are saying that to prove that line segment AF and line segment EC, are you looking the two line segments here, AF and EC? Observe, AF and EC are the two line segments we have given. They divide the line BD into three equal parts, or diagonal BD into three equal parts. So who can be the three parts over there? Can you separate the three parts of BD here? Suppose if I say, tell me some parts of the diagonal BD. So one part can be QB, second part can be C, in the middle PQ, and the last part can be here DP. So if I want to prove here these lines AF and EC are trisecting the diagonal BD, means these three parts DP, PQ and BQ are equal, then only we can say that they are trisected. Trisected means dividing into three equal parts, not dividing only in three parts. Okay, so if they are dividing into three equal parts, we can say that yes, it is trisected. So we need to prove basically here dp is equal to pq is equal to bq. These three parts we have to prove equal. Already three parts we have given, but they need to be proved equal to say that they are trisected. The diagonal BD is trisected. Okay, now let us start the question. First we shall write down in the proof. Now here also I will take some triangle and I will prove it. Okay, first of all I will make one triangle here. Suppose this is the required triangle, and in this triangle I will draw one line as usual as I have done in the previous question. Okay, so this is my triangle. Now this triangle, first of all I will take the name over here. Wait. Okay, now see the name of the triangle. Observe, I am taking here, you can see the main figure also. Accordingly I am taking the name. This point I am giving the name as P, this one I am giving the name as A, and this I am giving as B. Okay, so look at, I have taken one triangle PAB. Okay, PAB, one triangle is given in the question. There is no problem. Now E is a midpoint of AB. Okay, okay. One problem is done over here, that we have taken the site in a wrong manner. So wait, once again we'll give the name. The names we have not given in a proper way. E is a midpoint of AB. So we'll do one thing. Here I am taking the point A. Here I am taking the point B. And then I think here can be taken the point P. PB. Wait. Names I am giving in a wrong manner. This I think this can be given A. This can be given B. And this can be given as P. Yes. Now see, it is in a proper manner. And this point I am giving the name as E. And this point now it is, look at the triangle PAB. Okay, only PAB I have not taken in the same way as in the figure they have given to us. But one triangle PAB is there. I have taken triangle BAP. Okay, now you see on the side AB, point E is given to us, and on the side PB, point Q is given to us. Now, here can we apply converse of midpoint theorem? Yes, observe, E is given as a midpoint of site AB. So E is one of the midpoint. But the main hurdle now to apply the converse of midpoint theorem, the main hurdle is EQ is not parallel to AP. If EQ is parallel to AP, then Q will be also midpoint of PB as per the converse of midpoint theorem. Okay, but here we have not given that EQ is parallel to AP. However, we have given that ABCD is a parallelogram. So AB and CD are parallel, AD and BC are parallel. So if we take this particular triangle set right now, we are going to stop because EQ and AP are not parallel. So let us see how we can prove it. First, the EQ and AP are parallel. First, we shall write down in the solution. See, since ABCD is a parallelogram, ABCD is a parallelogram, and we know that in a parallelogram side opposite to each other are parallel as well as equal. So AB is parallel to CD and AB is equal to CD, that we know. We can say that here there is an opposite sides of parallelogram. Okay, now further see, AB and CD are equal, so half of AB will be equal to half of CD. For example, 10 will be equal to 10, so half of 10 means 5 will be equal to another half of 10, that is 5. So here I will say that, or, and here one more thing, AB and CD are parallel, so part of AB and part of CD will be also parallel. So observe, part of AB means AE I am taking here, and part of CD means I am taking CF over here. So AE and CF will be also parallel. So here I will write down AE is parallel to CF and half of AB is equal to half of CD. It is also possible. Okay, and half of AB and half of CD. See, who will be the half of AB? Here AE parallel to CF, I am writing as it is. And if I wish to find out who will be the half of AB, observe, we have given that in the question E is a midpoint of AB. So AE and BE both are the half of AB. Similarly, F is a midpoint of CD. So CF and DF will be also the half of CD because both are the half of a part of the CD over there. So here in place of AB we can write down AE, and in place of CD we can write down CF. So here it will come AE is equal to CF. And now you observe in a quadrilateral AECF, look at the quadrilateral AECF, we got one pair of opposite sides, that is AE and CF, are parallel as well as equal. And we know that if in a quadrilateral one pair of opposite side is parallel and equal, then it will be a parallelogram. So here we shall write down, which implies that AECF is a parallelogram. Reason we can give, since one pair of opposite side is parallel and equal both. Okay, now see, here we stopped because EQ and AP were not parallel. Now observe, EQ and AP are the opposite side of parallelogram AECF, means part of the opposite side of parallelogram AECF. Now see, AECF is a parallelogram, so AF and CE will be parallel, and EQ and AP are the part of that, so they will be parallel. So now this triangle I will take it down if it is possible, otherwise I will keep it here only. Since triangle you have seen, I am taking now that triangle, now considering the triangle downside. So now I am writing, now in triangle BAP, now in triangle BAP, E is midpoint of AB, that is given in the question. Okay, and second thing we'll write down here, second given is required, line through E we required parallel to the third side, and EQ is parallel to AP. Reason can be given here, since AECF is parallelogram. AECF is a parallelogram. Okay, we can say that therefore by converse of midpoint theorem, converse of midpoint theorem. Okay, what we can say, the another point. Who is the another point here? That is Q. Q will be a midpoint of PP. So we can say that by converse of midpoint theorem, Q is a midpoint of BP. Okay, and if Q is a midpoint of BP, means BQ and PQ will be both same. So we can say that therefore BQ is equal to PQ. Equation number we got here 1. No, the solution is not over up till now. We have reached more than half of the solution. Okay, so see, Q is a midpoint of BP, so BQ and PQ will be equal. Now once again I am taking the one more triangle, and in that once again I will apply the converse of midpoint theorem. So see, one triangle I have taken here now. Now this triangle I am placing here, and once again I will take one more triangle. Now look at the main figure, from that which triangle I am taking it. See, you are looking now one triangle CDQ. Are you looking at the triangle CDQ? See, that triangle is not drawn exactly in the same way as we look, but triangle is there, CDQ, and in the triangle CDQ, one midpoint we have given F. F is a midpoint of CD. So let us draw first triangle CDQ. Here I am taking one triangle C, then this point I am taking D. I may be wrong, we'll correct it later if it is wrong, and this point I am taking as F. Okay, now you observe CDQ I have taken, F is a midpoint of CD. Okay, and in this triangle you observe P is a point given on the side DQ. So DQ should come in the front. Let me check. Okay, DQ is not coming in the front. DQ is required on this side. So we need to change over here. Let me adopt this one. Here we'll do one thing. Yes, here this point I am taking D and this point I am taking C. Again F is the midpoint of CD, that doesn't make any change. But now here I can take a point P. Observe, P is one of the point on the side DQ. See, I am showing you the figure again and again so you can compare. Observe, P is a point coming on the line DQ. Okay, and triangle we have taken here CDQ. F is the midpoint of CD. So now suppose if I take F is the midpoint of CD, so observe F is midpoint of CD. But can we say that FP is parallel to CQ? Observe again, FP and CQ, are they parallel? Okay, look it in the main figure. FP is parallel to CQ. Observe FP and CQ again part of the parallel sides AF and CE. How AF and CE are parallel? Because we have proved earlier AECF is parallelogram. So they they will be parallel. Okay. So now we shall write down, at last we'll write down here in triangle DCQ. Now in triangle DCQ, F is midpoint of CD, one thing, and second thing we can write down here, FP is parallel to CQ. Reason we can give here, AECF is parallelogram. AECF is a parallelogram. Now we can say therefore by converse of midpoint theorem, again we can apply converse of midpoint theorem. Converse of midpoint theorem, we can say that P is a midpoint of DQ. P is a midpoint of DQ. Okay, and if P is a midpoint of DQ, it shows DP and PQ are equal. Equation number second. Now at the last we need to compare equation first and second. Observe, in the equation first and second, their right hand side is same. So therefore we can say that their left hand side will be also same. So therefore by equation first and second, we can say that BQ is equal to DP is equal to PQ, because PQ is a common value over there. And observe, this is only requirement of the question. See, we have written in the beginning only BQ, DP and PQ. We are going to prove equal. Okay, so see, I will show you the to prove section, DP, PQ and DQ. So that was only required to be proved. Okay, so now this question gets over. We have consumed a lot of time in these two questions only, because these two questions, they are theoretical also completely and lengthy also. Okay, next time we can start the last question of the exercise 8.2, that is question number 7, followed by one theorem which is required to be proved, and then if time remain we shall start the solved example. Otherwise it will be continued in the next further sessions. Okay, thank you.